Implicit Differentiation, Part 4. To find second derivatives, we take the derivative, d dx, of the first derivative, dy dx. So just symbolically, that's a d times y, so d squared y, over this dx squared. But we like to think of this dx as its own thing, so this d and this x are attached to each other. So we'll write this as d squared y over dx squared. And that's not what we say out loud. What this stands for, and the way we say it, is the second derivative of y with respect to x. So when we see this 2 here and this 2 here, that means we need to find the second derivative. So find the second derivative of y with respect to x if x cubed plus y squared is equal to 3x plus 2. So in order to find the second derivative, we need to first find the first derivative. So we'll take the derivative with respect to x of both sides of this in order to first find our first derivative, dy dx. So the derivative with respect to x of x cubed is 3x squared, plus the derivative of y squared with respect to x will be 2y times the derivative of y with respect to x, dy dx. And that's equal to the derivative with respect to x of 3x, which is 3, plus the derivative of a constant 2 with respect to x, which is 0. And we want to solve for this dy dx first. So figure out what our first derivative is. So we'll subtract 3x squared from both sides. So we have 2y dy dx is equal to 3 minus 3x squared. And then we can divide both sides by 2y. So we have dy dx is equal to 3 minus 3x squared over 2y. And then let's factor out a 3. So dy dx is equal to 3 times 1 minus x squared over 2y. And that is our dy dx. But we're not done. We need to find the derivative of this with respect to x. But we'll definitely need some more space. To summarize, in order to find the second derivative implicitly, we start by finding dy dx, which is the first derivative. And that's as we've been doing with implicit differentiation in general. So we differentiate, making sure that we're multiplying any derivatives of y with respect to x by dy dx, and then we solve for dy dx. Then we need to take the derivative of our dy dx, so the derivative of our first derivative, and that will give us our second derivative. But when we do this, we're going to end up with dy dx's inside of our second derivative, which is just a mess. We want our second derivative to only have x's and y's. Luckily, we know what dy dx is equal to in terms of x and y. And we're going to substitute that into any dy dx's in the second derivative. Then all that's left is to simplify.